Okay, in this section we're going to be looking at area bounded by the curves. This is probably one of the most difficult sections that we will cover this semester, so you want to make sure you really practice your math lab. Okay, so we're going to go over a couple of different scenarios and things that you do. So the first one says find the area of the region bounded by the graphs of y equal x squared plus 1 and y equal x, and it gives you for x between 0 and 2. This is the easiest kind. When they give you this, you think, hallelujah, okay? What you know from that is you know you're going to go from 0 to 2, okay? But you need to know which graph is on top and which graph is on bottom, because it's always top graph minus bottom. So let's take these two graphs and look and see which one's on top and which one's on bottom. So I'm only concerned about 0 to 2. So let's graph x squared plus 1 from 0 to 2. Now hopefully you remember how to graph it, but if you don't, I'm going to t-table it real quick for you, and I'm only caring about the values between 0 and 2. So I'm going to plug in 0, plug in 1, and plug in 2 for x and see what y is. So if I plug in 0 for x, I get out 1. If I plug in 1 for x, I get 1 squared, which is 1 plus 1 is 2. And if I plug in 2 for x, I get 2 squared is 4 plus 1 is 5. So let's plot those ordered pairs. Okay, we'll do this one in green. So I have 0, 1, I have 1, 2, and I have 2, 5. So that's a parabola, and this is that part of the curve. Okay, and then I have y equal x is my other one. And again, I'm only concerned about x values in between 0, 1, and 2. So this is easy. If I plug those in for x, I just get those same numbers out. 0, 1, 2. So let's plot that one in red. So 0, 0, 1, 1, and 2, 2. So that's this line. So I want the area bounded by those two curves. That one. Alright, so let me erase my t-tables and start back over. Alright, so I know that I want to go from 0 to 2, and it's top graph minus bottom graph. So which graph was on top? This one was, the curve, and then this one was on bottom. So it would be x squared plus 1 minus the bottom graph, which is just x. I like to put those parentheses there. I want to get you in the habit of doing that, because if you've got more than one term there, you'll have to distribute. So integral from 0 to 2 of x squared plus 1 minus x dx. Alright, so if I integrated this, if I add 1 to it, divide by 3, then I just add an x in here, I integrate. I end up getting 1/3 x cubed plus x minus 1/2 x squared, and I'm integrating it from 0 to 2. Okay? So to make life a little faster for me in this video, so you didn't have too much to download, let me double check that I plugged it in my calculator right. 1/3 x cubed plus x minus 1/2 x squared. Alright, so if we evaluated that, if we plugged in a 2 first, I get 8/3. And if I plug in a 0 here, here, and here, everything's going to zero out. So my answer is just 8/3. Okay, so again, the nice kind is when they give us that. Most of the time we're not given that. So I said, all right, let's look at the next case when you're just given the graphs and you're not told from what to what. Okay, something like this. So I gave you some steps. The first step is to set them equal to each other. You want to set these values equal to each other. Okay, and you want to solve this. So let's take everybody over, so that becomes a positive x squared, and then I have my positive x, and that becomes a negative 2. And if we factor to solve this quadratic, we get x plus 2, x minus 1. So this tells me that I'm going from negative 2 to 1. That's what that tells me. Okay, those limits of integration. But now I need to know top graph minus bottom graph. Okay, which one of those two is on top? It's really easy to do this. You've got these two graphs. So what I did is I told you take your limits of integration and pick a number in between. So you want to go in between -2 and 1. So I pick 0 because it's easy. So what I'm going to do is plug in 0 here, and I'm going to plug in 0 here. The highest value is the graph on top. The lowest value is the graph on bottom. So if I plug in a 0 there, I just get y equal 2, right? And if I plug it in here, I just get y equal 0. So the bigger one is your top graph, the smaller one is your bottom graph. So then I can see that it's top graph minus bottom graph. So integral from -2 to 1 of 2 minus x squared minus x dx. Okay, so to integrate that 2, I just add an x, and here I'm adding 1 divided by 3, and here I'm adding 1 divided by 2. So I get 2x minus 1/3 x cubed minus 1/2 x squared, and I'm going to integrate it from -2 to 1. So again, I'd plug in a 1 and I'd plug in a -2. Alright, so again, I'm going to make sure I have it programmed in right. 2x minus 1/3 x cubed minus 1/2 x, I did not have it plugged in right, squared. Alright, so now I can do it. Alright, if I plug in a 1, I get 7/6. And if I plug in a -2, let me get there. If I plug in a -2, I get a -10/3. So you got 7/6 plus 10/3, or 7/6 plus 20/6, right? If I multiply both those by 2 to get a common denominator, so 27/6, which you can reduce that by 3 to 9/2. Okay, so again, when you get those limits of integration, to decide which one's on top or bottom, pick a number that falls in between those. So I picked 0 and plug it in both graphs. The highest value is the top one, the lowest value is the bottom one. Alright, another one. Find the area of the region bounded by the graph of y equals x squared minus 3x minus 4 and the x-axis. Okay, so we know here's the x-axis. What I'm trying to decide if I have a curve like this where I'm looking for this area, or if I have a curve that does this and I'm looking for this area. Okay, I need to see if the x-axis is the one on the top minus the graph on the bottom, or if it's the graph on top minus the x-axis on the bottom. I got to see which case I have. Okay, so I told you how to do that. First thing you're going to do is set your graph equal to 0 to get your limits of integration. So it'll be x minus 4, x plus 1 equals 0. So x is 4 and x is -1. So that tells me I'm going from -1 to 4. Okay, so I have that. All right, now if you thought about it and you said, all right, let's pick a number in between -1 and 4, again, I'm going to pick 0 anytime I can. You've got two graphs. And the x-axis is y equals 0, okay? Remember that is y equals 0. Those are your two graphs. So I'm going to plug in 0 for both. So if I plug in 0 here and here, this graph comes out to a -4, and there's no place to change this one. This one's 0. So the biggest one is the one that's on top, so that tells me this one's on top. And then this one has to be the bottom graph. So it's top graph minus the bottom graph. So this one, it's real important to see that we have to distribute that negative. So I need to integrate a -x squared, a positive 3x, and a positive 4. Okay. So add 1 to it, divide by the new power, and then add an x. So I get -1/3 x cubed plus 3/2 x squared plus 4x. And I want to integrate it from -1 to 4. So double check my calculator. I've got negative 1/3 x cubed plus 3/2 x squared plus 4x. Alright, so I'm going to try to save some time really quick because I don't want this to become too long. So if I plug in 4 and I plug in -1, I'm ending up with 125/6. So make sure you can get that answer later with your own calculator. Alright, and finally we have this one. Okay, this one is the worst one for sure. Okay, what if the graphs intersect in more than one place? You're going to have to set up two integrals. It means, what if I have one graph doing this and one graph doing that, where you can see here green's on top and here blue's on top. So you have two separate regions with the graphs being on top. Alright, so the first thing is to do set them equal to find out where you're integrating. Okay. Alright, so if I take everything that way, I'm going to add the x squared. So those cancel, and I'm going to subtract the 2x. So end up with 3x cubed minus 12x equals 0. Take out a 3x. And then I can keep factoring it. Difference of squares. So I get x is 0, x is -2, and x is 2. So it tells me I have two integrals. I go from -2 to 0, top minus bottom, and from 0 to 2, top minus bottom. So I've got to fill in both of those. Got to figure out which graph is on top. Okay. So 3x cubed minus x squared minus 10x is 1. And I'm going to have to erase all this to give myself some room. And the other one is -x squared plus 2x. Okay, so let's see. First of all, I need to pick a number in between -2 and 0. So let's pick -1. So I'm going to plug in -1 here, here, and here and see what I get. Alright, and -1 cubed is -1 times 3 is -3. Alright, -1 squared is 1 times that negative out front is -1, and -1 times 10 is positive 10. So I get -4 plus 10, I get 6. And if I plug it in here, a -1, excuse me, here and here, I get -1 squared is 1 times that negative out front would be -1, and then here I would get a minus 2. So this is top and this is bottom. So this one is 3x cubed minus x squared minus 10x minus -x squared plus 2x. I'm going to have to write that better. Alright, the other one's always flopped, okay, but now let's plug in a 1 instead and just double check. We'll plug in a 1. So if I plug in a 1, because 1's in between 0 and 2, if I plug in a 1, I get 3 minus 1 minus 10, or negative, no, 2 minus 10, -8. And if I plug in a 1 here, I get -1 plus 2, or 1. So now they're reversed. This one's on top. Okay, so let's give myself plenty of room to write that neat. So they're reversed. Usually that's the way it works. Okay. So here we go. On this one, I have -2 to 0, and it was 3x cubed minus x squared minus 10x minus -x squared plus 2x plus, alright, and then the other one was just flip-flopped 0 to 2, and it was this one minus this one. So I told you these were a pain, okay, but they all work out. Alright, so if I distribute that negative, the x squares are going to cancel. I'm going to have to skip some steps to save some room. And I'm going to get a -12x. Now this one should be exactly opposite signs. Okay, because my -x squares are going to end up canceling after I distribute the negative. I'm going to end up with 2x and a positive 10x, so 12x minus 3x cubed. So you should end up with opposite signs when you integrate these. Alright, so that's going to be 3/4 x to the 4th minus 6x squared from negative 2 to 0. And that's going to be 6x squared minus 3/4 x to the 4th from 0 to 2. And what I'll do is add those values together. So really quickly, I'm going to plug that in to my calculator. Okay, so I do that one, and I evaluate it and plug in 0, and I plug in negative 2. Here I get 12. Alright, and then let's go change those signs. And now let's evaluate it from 2 to 0. And I get 12, so my area under the curve is 24. That's the worst kind of problem you could get. But anyway, go practice your MyMathLab and let me know if you have questions.